You're welcome to week 2 of this course, History and Philosophy of Science. And our topic today is the nature and scope of philosophy of science. I am Nora Onwumelu. The preceding week 1 focused on the various definitions of science, branches, aims, and the differences between science and non-science disciplines. In the second part of week 1, the scientific method was discussed in detail. In this first lecture of week 2, we shall be focusing on the nature and scope of philosophy of science. At the end of this lecture, you should be able to 1. Explain vividly the meaning of philosophy of science. 2. Outline the common characteristics of philosophy and science. 3. Recognize the scope of philosophy of science. And 4. Explain the nature of scientific method. Meaning of philosophy of science. It is important to note that the word philosophy was taken from two Greek words, namely philos, which means love, and sophia, which means wisdom. Literally saying, philosophy means love of wisdom. Therefore, to call a person a philosopher is to call him a lover of wisdom. This is because the Greeks believed that whoever tried to study and understand nature was trying to be wise. It may also interest you to know that philosophy of science is a branch of philosophy. Initially, philosophy embraced all the various disciplines. In other words, knowledge about the world in general was called philosophy. But, with specialization of knowledge, various disciplines, such as the sciences, were separated from philosophy. Philosophy of science is the systematic study of the nature of science, especially its methods, concepts, and presuppositions. It attempts to answer such questions as: what is science? What is the nature of scientific knowledge? How does it differ from other forms of knowledge? How do we arrive at a scientific truth? What are the aims and objectives of science? That is, what is the goal, end, or purpose of science? We have tried to answer these questions in week 1. There, we discussed definitions, branches, and aims of science. We tried to show the differences between science and non-science disciplines. We also examined the historical development of science in a general outline. In this unit, we shall examine the nature of science in a philosophical manner. Scientists work on the assumptions of some facts and on general principles. For example, one fundamental notion in science is the idea of law of nature. And the idea of law-governed universe assumes that the universe is uniform. So, the assumption of the uniformity of nature poses a problem which philosophy tries to explore. According to some philosophers, the laws of nature are not the same in the planets. Yet, the scientists use the same law of gravitation for all of them because of the scientific faith in the uniformity of nature. Philosophy questions the empirical generalizations which the scientists feel are unquestionable. Before we go on, let us discuss the common characteristics of philosophy and science. It is important for you to know that though philosophy and its offshoots, the small sciences, are not identical, yet they share a lot in common in their systematic pursuit of knowledge. Their common characteristics include: 1. They are critical, skeptical, and non-dogmatic in character or attitude. 2. They both show the curiosity to know and the courage to explore every question within no-go areas and heresy. 3. They both search for knowledge which is rational, systematic, universal, objective, certain, and verifiable. The demands for evidence or grounds of belief are also very important. Logic is central to both philosophy and science, and the principles of valid or true reasoning are important for both philosophy and scientific inquiry. 4. They both lay emphasis on method. The deductive and analytic methods are important for philosophy, while the deductive and inductive methods are important for the sciences. 5. They both search for general laws or principles and theories for explaining the nature, character, and functioning of the universe or any of its parts. 6. Whereas philosophy focuses on the general principles and fundamental assumptions of the sciences, such as the law of uniformity of nature, science focuses on both the general laws and particular laws, such as the law of inheritance. 7. Philosophy is very reflective in that it meditates or reflects on the nature, methods, and concepts of the sciences. That is why we have philosophy of science. Scope of philosophy of science. From what we have discussed so far, philosophy of science embraces the following. 1. Definition of science. Here, such questions as the nature, branches, and meaning of science are explored. This had been discussed in week 1. 2. The aims, end, or purpose of science. Philosophy tries to understand the objective of engaging in scientific activities. It also inquires into the utility or uses of science. Scientific knowledge, as we now know, leads the world to attaining progress and better conditions. Therefore, modern science has contributed to improving the lots of man with regards to food, plant production, housing, health, clothing, communication, etc. Science has also influenced other disciplines of man's engagement. This is with regards to the skill or art of doing things. And we now know that the skill or art of producing and the application of science starts with the art of correct observation and experience. 3. The methods of science. Philosophers examine the experimental method. The practice of scientists, as was the focus in week 1, is done in the following steps. The scientist works with some data to solve a particular problem. He formulates various hypotheses which, if true, will solve that particular problem. He experiments to discriminate among the competing hypotheses. The performed experiment selects and adopts the hypothesis that verifies the problem. This practice for the philosopher of science filled up with problems because it is just like the activity of every person. For instance, a female cook can adopt this procedure to establish that she is an excellent home economic woman. The philosopher tries to find out how true the result obtained through this method is. To the philosopher, scientific opinions, belief, facts, and results are not the only criteria of knowledge. Some scientific beliefs often conflict with each other. Therefore, they are sometimes unstable, even with the experimental data, while a sound philosophical knowledge is always permanent. With the established result of empirical sciences, it is difficult for the scientist to change his opinions. For instance, the early scientists viewed the world as being flat. Later, when it was proposed that the earth was spherical, it took the scientists some time to change their view. But philosophy, as a reflective discipline, sometimes rethinks its own views. A hasty implementation of some scientific discoveries, like the atomic bomb explosion in Hiroshima and Nagasaki in the Second World War, does not improve human life. A sound philosophy must encourage the examination of scientific inventions. This is why philosophy of science criticizes scientific opinions and practice. When the scientific method is properly analyzed by philosophy, it describes or presents an ideal situation which every scientific activity or practice tries to satisfy. You will learn more of this in the next point to be explained. 4. Analysis of scientific concepts and theories. Do you know what a concept is? It is an idea of a class of objects or a general notion. Many concepts are encountered in science. Let's enumerate some of them. 1. There are general concepts which apply to science in general, such as science, facts, theory, law, motion, etc. 2. There are concepts which apply to scientific methods in general, such as observation, experiment, hypothesis, theory, induction, deduction, etc. 3. There are those concepts that are basic to various branches of science, such as time, atom, electron, proton, as found in the physical sciences, and gene, cell, in the biological sciences, etc. You may not be aware that philosophy tries to analyze these concepts. In fact, one of the chief tasks of philosophy is the analysis of the language of science, or semiotic. Semiotic is also called the theory of science and the signification of terms, or semantics. Semantics means the science of the meaning of words. Semantics, as a department of semiotics, is the study of the relation of signs to the objects to which the signs refer to, or designate, or are applicable. For instance, if one uses the word cell, philosophers try to study the relationship of that word, cell, to the object to which it refers. Philosophers also analyze theories. Apart from studying the relationship of this word, theory, to what it refers, philosophers also present some constraints or limitations which are used in establishing the quality and nature of theories for good scientific practice. These limitations are the criteria for determining the practicability of a hypothesis. One of these criteria is falsifiability. This principle was introduced by Karl Popper, and it is meant to take care of those statements which cannot be verified now and which may be verified in future. Such statements have to be accepted in principle until experience or test falsifies or verifies them. For example, a theory about the origin of the universe may not be verifiable in the meantime, but it can be falsified. The falsifiability principle advocates that a theory be treated as a possible scientific one if there are reasonable grounds to believe it until it has been shown to be false. Let us continue with the discussion on the criteria for determining how practicable a hypothesis is. The next criterion is significance. Significance is what something means. We have earlier discussed this in connection with analysis of concepts. The final criterion is called paradigm conservation. It is a device against impractical proposal. It suggests that insistence on the past model or theory is preferable when a new model conflicts with the past one. It is used especially if a reliable datum has been previously established by hypotheses and laws. Thus, conflicting explanations of data can be offered on the basis of paradigm conservation. The last subtopic on our discussion on the scope of philosophy of science is the nature and character of scientific knowledge and its relation to other branches of knowledge. If you will recall from an earlier class, you have studied the characteristics of the scientific knowledge and also the differences between science and non-science. But we can still summarize the characteristics here. A genuine scientific knowledge, according to philosophy, is characterized by 1. Systematicness. This means that the propositions of any scientific knowledge must be logically related. They must exhibit a deductive character such that no proposition which is true could relate logically to a false one. Scientific knowledge must be pursued in a systematic manner. The steps leading to results or conclusion must be repeatable or be capable of being repeated. This makes it possible for a true scientific statement, proposition, or theory to guarantee certainty. 2. Universality. Here, every true scientific statement must show a universal character. This means that it must be true in all cases under the same conditions. If an exception occurs, the preposition must be so qualified and the limit to its applicability must be indicated. 3. Objectivity. This refers to the absence of personal bias to recognize that there is a fixed external reality which refuses to quit whether we accept it, know it, or not. Thus, a scientific proposition or statement must be true irrespective of the interest of the scientist. It must be factual and non-subjective. All experts in the area must be able to confirm through logical or experimental demonstration the truth of the statement. Let us look at the nature of the scientific method. Do you still remember what is meant by the scientific method? You will recall that it was the topic of discussion in week 1. Since we have discussed the steps of the scientific method, let us see the philosophy behind the method. A brief introduction will help you understand this topic. Philosophy has many branches and they include metaphysics, epistemology, logic, ethics, aesthetics. But only epistemology and logic are relevant to the discussion on the philosophy of science. Epistemology and logic are branches of methodology. Methodology is one of the divisions of philosophy. It deals with ways of attaining knowledge, that is, the process of intellectual inquiry, research, and reasoning. In philosophy, epistemology is the branch that deals with how we discover true knowledge from a direct process of investigation, while logic enables us to arrive at new knowledge from existing knowledge. This then means that the process of discovering new knowledge is not the same as the process of inferring or deducing knowledge from implications of what we already know. Thus, the differences between the two are: 1. While logic is concerned with validity or soundness, epistemology is concerned with the truth of our assertions or propositions. 2. Epistemology is important in the process of discovery and research, while logic is important for the systemization of knowledge and also in deducing new knowledge from what we have already discovered. These two aspects of methodology can be found within the scientific method, and they are essential for all branches of knowledge. We shall discuss logic, then show where it can be found within the scientific method. Logic, as you may know, is concerned with human reasoning or thought. It studies the structure of human thought as well as the principles or laws of valid reasoning. It is concerned with the validity or soundness of the inferences and conclusions which we make in our arguments. To reason is to infer, to judge, or to argue. To infer or argue is to move from certain premises to other premises or conclusions. That which is inferred from another premise is the conclusion. In an argument or reasoning, we move from knowledge to new knowledge, or from a supposition or premise to that which validly follows from it. Before we proceed any further, we need to explain the terms premise and conclusion. When we have a sequence, that is, a number of statements in addition to a claim, then we have an argument. Sequence itself is made up of two or more statements, while the claiming is one of the statements called the conclusion. Other statements in an argument are called premises. The following is an example of an argument. All dogs are mammals. All mammals are animals. Therefore, all dogs are animals. The first two statements are called premises, while the last statement is the conclusion. Thus, conclusions are always derived from premises. Let us look at the two types of logic which are relevant to the scientific method. They are deductive logic and inductive logic. Deductive logic. This is where we move from a set of premises which we assume to be true to a conclusion. If we reason correctly according to the rules of deductive logic or method of reasoning, then the conclusion will be valid. And if the premises are true, then the conclusion will be necessarily true. For example, the following argument is a deductive one. All men are mortal. John is man. Therefore, John is mortal. The conclusion John is mortal is a deductive knowledge. Its truth is derived from logical implications that it follows which happen to be true at the same time. Therefore, in deductive method, we move from a general principle to particular instances which fall under such a deductive reasoning. It is applied mainly in formal logic, mathematics, and philosophy. But science also applies the method especially with regard to the organization and systemization of knowledge, as well as in making inferences from what we already know. Deductive method is also called Platonic method. It gives knowledge that is certain. Inductive logic. This is the type of reasoning where we go from some particular statements to a general conclusion. It is used in empirical or scientific generalizations. For example, many Africans are black, therefore all Africans are black. The inductive method is also called the Baconian method because of the founder, Francis Bacon. This method of discovery emphasizes observation, experimentation, verification, and theory construction. The problem with induction is that it is possible for a member of the class to turn out to be different from what have been generalized for all the members of the class. For instance, some Africans are white, such as in South Africa. Therefore, induction gives us probable knowledge. Probability shows the degree of reliance which we can place on the inductive generalization. To say that an event is probable is to say that it is likely to occur. When the scientists talk of probability, they must indicate the degree of probability of the occurrence of the event in question. A holistic look at the scientific method identifies two phases. 1. The method of discovery, which is inductive. It emphasizes observation, experimentation, verification, and theory construction. And 2. The method of organization of scientific knowledge, which is deductive and systematic. This means that logical reasoning runs through the scientific method, and it is the main tool in 1. Formulating hypotheses, 2. Judging the correctness of ideas conjured up by imagination and intuition, 3. Planning experiments and deciding what observations to make, 4. Assessing evidence and interpreting new facts, 5. Making generalizations, and 6. Finding extensions and applications of a discovery. So far, we have discussed the meaning of the philosophy of science, its scope and common characteristics, and the nature of the scientific method. While doing this, we focused on topics like analysis of scientific concepts and theories, the nature and character of scientific knowledge, and its relation to other branches of knowledge. We also studied the nature of scientific method. In all, we learned that philosophy of science basically guides science through the way it chooses to gain knowledge of nature. I hope you enjoyed this class. See you at the next lecture. Bye-bye.